In my last video, I explained you a shortcut method when you have equation like first one number, the reciprocal is equal to 13 by 6. So let us work out this one. This is the first one, x by x plus 1 within square root, and its reciprocal is root of x plus 1 by x. So a number is reciprocal. So I would like to put the right hand side also as a number and its reciprocal. Yes, it is 2 by 3 plus 3 by 2. Check it. 2 by 3 plus 3 by 2. So 2 2s are 4 plus 9 divided by 6. So a number plus its reciprocal is 2 by 3, a number plus its reciprocal. That means this number may be 2 by 3 or it may be 3 by 2. Now we can easily solve it. So root of x by x plus 1 is 2 by 3 or root of x by x plus 1 is equal to 3 by 2. So now square both sides, you get x by x plus 1 is equal to 4 by 9. Cross multiply, 9x is equal to 4x plus 4. Bring x terms on left hand side, 5x is equal to 4. X is equal to 4 by 5. This is one root of this equation. Another one, here you square, you get x by x plus 1 is equal to 9 by 4. Cross multiply, 4x is equal to 9x plus 9. 4x is equal to 9x plus 9, then take x to that side, so 5x is equal to minus 9, x is equal to minus 9 divided by 5. So the solution are 4 by 5 minus 9 by 5. Okay. Now I would like to do some more problems without using any formula. Again a trick. X times x plus 1 is equal to 42. X plus 1 times x plus 2 is equal to 20. If you multiply, you get a quadratic equation. X square plus x minus 42 is equal to 0. Here if you multiply, you get x square plus 3x plus 2 is equal to 20. But I am going to use a technique here. Supposing x is an integer, x and x plus 1 are two consecutive integers. X and x plus 1 are two consecutive integers. Similarly, here if x is integer, x plus 1 and x plus 2 are two consecutive integers. So let me try to put the right hand side as a product of two consecutive integers. 6 7s are 42. So x times x plus 1 is 6 times 7. Since I said integers, it may be negative. So minus 7 times minus 6. So it is both 6 times 7 or minus 7 times minus 6. In this case, the smaller number is x. Therefore, x is equal to 6 or minus 7. So this technique can be used when the left hand side is like this. An integer multiplied by its consecutive integer. Right hand side can also be put as a product of two consecutive integers. This is possible only in such cases. Okay, similarly, let us try the right hand side. X plus 1, x plus 2, if they are integers, then I can try the right hand side 20 is a product of two integers, 4 times 5 or minus 5 times minus 4. In this case, the smaller one is x plus 1, so x plus 1 is 4 or x plus 1 is minus 5. So x is equal to 3 or x is equal to minus 6. These are some of the interesting techniques. Okay. I am going to introduce formula for solving a problem. So this can be useful for any quadratic equation. This formula can be used for any quadratic equation. X is equal to minus b plus or minus root of b square minus 4ac whole divided by 2a. Minus b plus or minus root of b square minus 4ac whole divided by 2a. This is the formula. A is coefficient of x square, b is coefficient of x, c is a constant term. So you have to by heart this formula, minus b plus or minus root of b square minus 4ac whole divided by 2a. Let us see how we can use this formula to solve the equation. Coefficient of x square is 1, a is equal to 1. Coefficient of x is plus 5, so b is equal to 5. Constant term c is minus 2. Then use this formula, x is equal to minus b minus 5 plus or minus root of b square 5 square 25 minus 4ac 4 into a into c 4 ones are 4 into minus 4 minus 16 minus of minus plus 16 divided by 2 times a 2 times. So 25 plus 16 41. So minus 5 plus or minus root 41 divided by 2. You cannot simplify this because it is a irrational number. So whenever we are going to have an irrational number, this formula is the only way of solving it. Okay, let me give you another question similar to this one. X square plus x minus 1 is equal to 0. Here coefficient of x square is 1, coefficient of x is 1, constant term is minus 1. So x is equal to minus b minus 1 plus or minus root of b square minus 4 into 1 into minus 1 minus of minus plus 4. So it is minus 1 plus or minus root 5 divided by 2. Here also we have irrational roots. Okay. Now let us recall the formula, minus b plus or minus root of b square minus 4ac whole divided by 2. Here this term b square minus 4ac is within square root. It is within square root. So if you have a negative value for b square minus 4ac, square root of a negative number is not real. Is not real. So when b square minus 4ac is negative, we cannot have a real roots. They call b square minus 4ac as discriminant. B square minus 4ac. This is called discriminant. If this discriminant is less than 0, no real roots. We call it as unreal roots or sometimes imaginary roots. Complex number, that's a different chapter. But we don't have real roots when the discriminant is negative. When the discriminant is 0, you have only root minus b by 2a. Minus b by 2a. Since it is a quadratic equation, we need two roots, but both roots are minus b by 2a. Therefore, we call it as equal roots. D is equal to 0 means real and equal. When D is greater than or equal to 0, real roots. So this you have to remember. B square minus 4ac, when it is negative, no real roots, unreal roots or imaginary roots. When discriminant is 0, real and equal. When the discriminant is greater than or equal to 0, simply real roots. Let me show you one simple example of unreal roots. This is a quadratic equation, no doubt. It's a quadratic equation. Here a is equal to 1, b is equal to 1, c is also equal to 1. B square minus 4ac is 1 minus 4 minus 3. Therefore, no real roots. When b square minus 4ac, the discriminant is negative, there is no real roots. Okay. Now let us see when we are given the roots, say the roots are alpha and beta for a quadratic equation. When we are given the roots, let us see how we can form the equation. Since alpha is a root, x minus alpha is a factor, and beta is another root, x minus beta is the other factor. Since alpha is one root, x minus alpha is a factor, beta is other root, x minus beta is also a factor. So x minus alpha multiplied by x minus beta is equal to 0 must be the equation whose roots are alpha and beta. X minus alpha multiplied by x minus beta equal to 0 must be the equation. If you multiply, you get the equation x square minus alpha x minus beta x. So minus of alpha plus beta x minus alpha into minus beta plus alpha beta, that is equal to 0. So when the roots are given, we need not worry about this. We can remember in this way, x square minus sum of the roots into x plus product of the roots is equal to 0. The roots are given, you need not write these steps. You can just add the roots, put here, multiply the roots, put here. X square minus sum of the roots into x plus product of the roots is equal to 0. X square minus sum of the roots into x plus product of the roots is equal to 0. Let me see some interesting examples. Let the roots are 2 and 3. Roots are 2 and 3. What is the sum? 2 plus 3, 5. What is the product? 2 into 3, 6. Therefore, the equation is going to be x square minus sum of the roots 5x plus product of the roots is equal to 0. So, the roots are 2 and 3. The equation must be x square minus 5x plus 6 is equal to 0. Supposing the roots are 2 and minus 5. No problem. Sum is 2 minus 5 minus 3. Product is 2 into minus 5 minus 10. But remember, x square minus sum of the roots. So minus of minus plus 3x plus product of the roots is equal to 0. So the equation is x square plus 3x minus 10 is equal to 0. Okay, what if the roots are fractions? Same idea. If the roots are 1 by 2 and 1 by 3, I'm going to apply the same idea. 1 by 2 plus 1 by 3, 5 by 6. 3 ones are 3 plus 2 by 2 3s are 6. So sum of the roots is 5 by 6. Product of the roots is 1 by 2 into 1 by 3, 1 by 6. So product is 1 by 6. So x square minus sum of the roots into x plus product of the roots. X square minus sum of the roots into x plus product of the roots. But we can multiply throughout by 6 to avoid the fractional form. This is correct, no doubt. This is correct, but we can multiply throughout by 6. 6x square minus 5x plus 1 equals 0. This is also correct. So, answer may be given either like this or like this. Both are same because you are simply multiplying this equation by 6 to get this equation. So for both the equations, the roots are 1 by 2 and 1 by 3, so they are same. So generally we avoid writing fractions in quadratic equation. Okay, one more. Sum based on this. When the roots are irrational, like 2 plus root 3 and 2 minus root 3. Same idea. Sum of the roots is equal to 2 plus root 3 plus 2 minus root 3. Root 3 will go 4. Product of the roots 2 plus root 3 into 2 minus root 3. This is of the form a plus b into a minus b, a square minus b square, a square is 4, b square is root 3 square 3. So 4 minus 3, 1. Therefore, the equation is going to be x square minus 4x plus 1 is equal to 0. Okay, ba?